Now we'll learn how to name covalent compounds, also called molecular compounds. And you can always spot a covalent compound versus ionic compounds because covalent compounds contain a nonmetal and another nonmetal. You'll see those on the top right of the periodic table. Ionic compounds usually contain a metal and a nonmetal. So in order to name a covalent compound, you need to indicate the number of each atom with the Greek prefixes you see on the left. And this is because they don't obey the same rules as ionic compounds. You can't tell what the charge is going to be on a covalent compound. They share electrons. They're not transferring electrons and forming ions. So they combine in different ratios, and you can't always tell by looking at the periodic table what those ratios are going to be. So we need to indicate the number of each atom in the compound. And we don't use mono if there's only one of the first element. So for example, something like CO you've probably recognized as carbon monoxide. So the mono tells you that there is only one oxygen, and there is only one carbon, but since it's the first element, we don't use mono for carbon. And how do you know which one goes on the left and which one goes on the right? Well, if you're writing the formula, the one that is on the left or bottommost of the periodic table, or the one that is the least electronegative, always goes on the left. So carbon monoxide versus carbon dioxide. So again, we don't use mono to show that there's only one of the first. So let's look at another example. N2O4, and in this compound we have 2 nitrogens and 4 oxygens. So we'll have to use Greek prefixes for both of those elements. So we have 2 of the nitrogen, so it's a dinitrogen, and 4 oxygens, so we'll call it tetraoxide. And sometimes people like to drop the A. So in some cases you might see this called tetroxide or pentoxide people use. Those are common with oxides, but I think those are optional. Let's take a look at one more example. We've got S2F10. Just count the number of each element. We have 2 sulfurs, so this one will be disulfur. We have 10 fluorines, so decafluoride.